Okay, if that is the case, let's go ahead and start our new section, section 3.2. And this section 3.2 is about the polynomial function and their graph. Okay, now before that, what is polynomial? Let's define that. Does anyone have idea of like polynomial function? Okay, before that, let's go ahead and start defining monomial. Have you heard the term monomial? Okay, so can you just give me an example of monomial? What is monomial? What is the example of monomial? Okay, now monomials can be any real number. Okay, so if you just take any real number, then that is a monomial. So let me take -1 or 0. These are the monomial. Okay, it can be any variable. Okay, so if we have variable, okay, let's take x with a exponent, a whole number. Let me take x squared, or x, or let me take different variable, y to the power 10. So we have a variable with a whole number as exponent, then that is also a monomial. Okay, monomial can be any real number. Monomial can be any variable with a whole number exponent. Okay, the exponent has to be a whole number. Okay, this is the exponent or the power. It has to be a whole number. Whole number means it's a 0 and all counting number, right? The 0, 1, 2, 3. So these are whole number. Okay, so if the exponent are 0, 1, 2, 3, 4, 5, right, then we take that as a monomial. If we have something like a to the power 1/2, is that a monomial or not? See, if we have a to the power 1/2, let's say a to the power 1/2. Now, is this monomial or not? It is not the monomial, and the reason is that our exponent is 1/2, and 1/2 is not a whole number. It is a fraction. Okay, so any real number is a monomial. Any variable with a whole number as exponent is a monomial. Also, if we have a number times a variable, so let's say we have a 2 times x to x, this is also a monomial. So if we have a number times some variable, okay, it's a monomial. Also we can take, it can be any number. Okay, so 3/4 times a to the power 5, this is also a monomial. Number times a variable, okay, with a whole number as exponent, that is a monomial. Or if we have a variable times variable, so let's take x squared times y cubed. So we have x squared. Okay, this is a x is a one variable with a whole number as exponent. We have a second variable with a whole number as exponent. So variable times variable, it is also monomial. Okay, so these are the examples of monomial. Any real number, they are the monomial. Okay, any variable with a whole number as exponent, they are also monomial. Okay, if we have a number, any real number times some variable, that is also monomial. Okay, if we have a variable times variable with a whole number as exponent, that is also a monomial. So all these are monomial. Okay, now if we combine two monomials with a plus or minus, we get, what do we call that? Binomial. Okay, now let's take one of these, let's take two monomial from here. Okay, so let's take x square, let me take x square and 2x, and these two monomial. So we have the two, so let me, okay, now we have these two monomial, x square and 2x. These monomials are connected by a sum here. Okay, then it becomes a binomial. Okay, so this is binomial. Monomial, we take monomial as a one term. Okay, so all these are one term. So this is one term, this is also a single term, this is also a single term. But if we connect two monomial with a sum or difference, then that becomes a binomial. Okay, similarly we have x square y cube minus 1. This is also a binomial. Again, binomial always has how many terms? 2 terms, and they have to be connected by plus or minus. Okay, not the product, not the division, like here. So if we simply take here, so we have so here we have the two variables x square and y cube, and these two are connected by product here. So this is not a 2 terms, this is 1 term. Okay, x square y cube is a monomial, but x square y cube minus 1 is a binomial. Okay, so if we have a monomial and they are connected by plus or minus, two monomial connected by plus or minus, that is a binomial. Okay, in the similar way, if we have a 3 terms, okay, which are connected by a plus, addition or a subtraction, and we call those as a trinomial. Okay, so let's take a 3 monomial. So we have like x cube negative 2x plus 1. So this is the 3 terms here. We have a 3 terms. X cube is a 1 term, negative 2x is a second term, and plus 1 is the third term. These 3 terms are connected by plus or minus, and if this is the case, we call this expression. Okay, this is our trinomial. So if we have a single term, it's a monomial. If we have a 2 terms, it's a binomial. If we have a 3 terms, it's a trinomial. Okay. Now polynomials, if we have a more than 3 terms, we call it polynomials. Okay. And you can also call monomial, binomial, trinomial as a polynomials. All these are the polynomials. But if we have a 1 term, it has a specific name, monomial. Okay. It's also polynomial with a 1 term is a monomial. Polynomial with a 2 term is binomial. Polynomial with a 3 terms is trinomial. But if we have an expression with more than 3 terms, we just call all them as a polynomial. Okay. So the examples can be, okay, let's have an example with a more than 4 terms. So if we have a x to the power 4 plus 3x cube negative 2y plus 4. Okay, so here we have more than 3 terms. So we just call polynomial. Okay, if we have like 6 terms, just a polynomial. But if you see 2 terms, be more specific, call it binomial. Okay, they are the polynomials. Okay, so here all these monomial, binomial, trinomial, all these are the polynomial function. Okay, and here the very key thing is that you must have a exponent as a whole number. Okay, that's the very important thing. So if you have a mathematical expression and if you have many terms, and if every variable has a whole number as an exponent, they are the polynomial. Okay, if the exponent is negative, if the exponent is a fraction or a decimal, they are not the polynomial function or polynomial expression. So can you just give me an example which is not a polynomial? What would be a expression which is not a polynomial? Just think a mathematical expression which has an exponent, variable having exponent, not a whole number. It can have a negative, like x to the power negative 1. That is not a polynomial. Or square root of x. That is not a polynomial. Okay. So to be a polynomial, we must have our exponent of the variable as a whole number. Okay. Now here, let's go ahead and define our polynomial function. If we know the polynomial expression, then we can easily define the polynomial function. So let's call f as a polynomial function. Okay. And if we have a function f of x, and if we can write the given function in this expression, so let me rewrite this expression. So we have a function, let's call our f of x, and if we can have our function as a to the power n, I'll just describe what are these, times x to the power n plus a to the n minus 1, x to the power n minus 1, okay, plus or minus, we can have minus a minus 1, sorry, a minus 2, x to the power n minus 2, and so on. Just we can just have infinitely many terms. Okay, and at the end we have a1x plus a naught. So if we have a function in this type, and here an minus 1, an minus 2, a1, a naught. These are any real number. Okay, these are just a number. Just we use this notation to represent a number here. So here, okay, a naught, a1, an, these are real valued constant, or these are any real number. Okay, and we have the an, the coefficient of this x to the power n, this is not equals to 0, and n is a non-negative integer. Okay, non-negative integer means what kind of number is non-negative integer? It's a whole number. Okay, so it can be 0. So it's 0, 1, 2, 3, 4, 5. These are the non-negative integer, or these are the whole number. The exponent, n is the exponent here. So n is the exponent of a variable x. Bless you. And this n has to be whole number. It can't be negative. It can't be fraction. Okay, this exponent has to be the our whole number. Now let's take an example. So if we have a function f of x equals, let me take this example here, x cube negative 2x plus 1. Now here we have this function. Okay, we have 3 terms here. Now, so here for this function, what is the input? Our input is x, right? So x represents the input, f of x is the output. Now we take the exponent of the input. Now what is the exponent of this x? We have 3, right? This x has the exponent. What is the exponent of this x? 1, right? And we have 1. 1 is a constant, and whatever the constant, we can just rewrite 1 as a 1 times 1, right? And 1 is, can we rewrite 1 as a 1 times x to the power 0? If we have anything like other than 0, if we have any number to a power 0, it is always equals to 1. But except 0 to the power 0, that is undefined. Okay, so if you have any number like a fraction, decimal, or a variable, and it has exponent 0, it is always equals to 1. So this 1 constant, it always has a exponent as a 0. Okay, now let me go back to monomial one more time here. Now here we also need to define the degree of monomial. We also need to define the degree of binomial, trinomial, and a degree of polynomial. Okay, so here degree means the exponent, the highest, the exponent of the variables. Okay, if we are talking about the monomial, okay, so the degree means we are looking for the sum of exponent of the variables. That's the degree. Okay, now let's take -1. Now in -1, do we have any variable? So degree means always sum of exponent of the variable, okay, not the number. So we look for the variable and we look for its exponent. Now for in -1 is a constant, right? Like here, we can always rewrite our negative number as, we can always rewrite our real number as a -1 times any variable to the power 0. We can always rewrite any real number as a real number times any variable to the power 0, because x to the power 0 is always 1. Okay, so if that is the case, what will be our degree for -1? Degree for -1 is 0. What is the degree of 0? 0. If you have a constant number, the degree is always 0. So what would be the degree for x square? 2. What is the degree of y to the power 10? 10. What is the degree of 2x? 1. What is the degree of a to the power 5? 5. What is the degree of x square y cube? Sum of exponent of every variable. Now how many variable we have? We have 2 variable, x and y. And what is the sum of the exponent? 2 plus 3, that is 5. So 5 is the degree. So if we have a monomial, the degree is sum of exponent of each variable. That is the degree. Okay. Now in the binomial, we have the 2 term, right? So we have 2 term, x square and 2x. Now let's find the degree of each term. What is the degree of this x square? 2, right? And what is the degree of 2x? 1. Now if we have binomial, trinomial or polynomial, the degree is always the highest degree. So we have more than one terms. It means we take the degree we always take the highest degree here. So what is the highest degree? 2, right? So 2 is the degree of this binomial. So in order to find the degree of polynomial, you find the degree of each term, okay? And whichever term has a highest degree, that same degree is the degree for the polynomial, okay? Now let's take the second binomial. We have this binomial. What is the degree of this first term? 5, right? 2 plus 3, 5. 2 plus 3, 5. And what is the degree of 1? It's a 0. And the highest degree is 5. So 5 is the degree for this binomial. Okay, now let's go to the trinomial. What is the degree of x cube? 3. What is the degree of 2x? 1. The degree of constant is 0. The highest degree is 3. So 3 is the degree of this trinomial. Okay, now let's go to this polynomial. X to the power 4 has a degree 4. 3x cube has a degree 3. 2y has a degree 1. 4 has a degree 0. And the highest degree is 4. So 4 is the degree for this polynomial. So 4 is the degree. Okay, so if you know how to find the degree of monomial, then you should be able to find the degree of the remaining binomial, trinomial and polynomial. Okay, and degree of monomial is sum of exponent of every variable in that monomial. Sometime we might have a 3 variable, so you're gonna add exponent of each variable. Okay, like for example, so if we have x square y cube g to the power 10, now what is the degree here? Degree of this is this a monomial, binomial or a trinomial? Monomial. Okay, to be a binomial you must have a plus, you must have a 2 terms with plus, okay, or minus. Now we have product here, so this is a monomial and the degree is 2 plus 3 plus 10, which is 15. So 15 is the degree for this monomial. So you are adding exponent of each variable. Okay, now in general, so we always write down the polynomial function in the descending order of degree. Okay, like if we go back here, now here the degree is, now this is a polynomial, the first term has a degree 4, the second term has a degree 3, third term has a degree 1 and fourth term has a degree 0. So 4, 3, 1, 0 is in the descending order, right? So that's how we write in standard form. So if you have a polynomial, make sure you always write in the descending order of degree. Okay, so highest degree first and the lowest degree at the end. Similarly, so here we have 3, 1, 0 is in the descending order. Okay, that's what it means here. So n is the degree, so we want to write degree in the descending order, so the next degree has to be n minus 1, right? Then n minus 2 all the way. So this x has a degree 1 and this x has a degree 0. So we have the degree in the terms in the ascending order. Okay, so polynomial, we always write the polynomial function in the descending order of exponent of the variables. Okay, now we have here examples and we need to find whether these are the polynomial function or not. We need to find the degree coefficient and we need to find the leading coefficient. Okay, now here I forgot to mention the about coefficient. What is coefficient? So if we have, okay, now let's go back here. So if we are taking this, okay, 2x, now what is the coefficient? Coefficient, these are the real number in front of the variable. Okay, so coefficient are the real numbers, are the constant number that we have in front of the variable. Okay, like here in front of x we have 2, right? So 2 is the coefficient here. So in front of a to the power 5 we have 3 over 4. So this is the coefficient for this term. Okay, similarly for x square term, what number do we have in front? 1, right? We don't write, but we always have 1 there, so 1 is the coefficient. Okay, so if we have for this x square y cube terms, the number in front is 1, so 1 is the coefficient. Okay, similarly here this term has a coefficient -2, this term has a coefficient 3, this term has a coefficient 1. Okay, for the constant, it's just a real number, so it itself is a coefficient. Okay, 4. So coefficient is a number that you see in front of a monomial. It can be any real number, fraction, decimal, or negative, positive. Okay, and the next leading coefficient means, now here, if we look for the term with the highest degree, and that term with the highest degree is the leading term, and its coefficient is leading coefficient. Okay, now here we have this polynomial. Now in this polynomial, in order to find the leading term, we find the term with the highest degree. Now can you tell me the term with the highest degree in this polynomial? Which is the term with the highest degree? X to the power 4, right? It has a degree 4. Now what is this coefficient? 1. So 1 is the leading coefficient. So you find the term with the highest degree. That term is a leading term. Okay, and the coefficient of the leading term is the leading coefficients. Okay, now let's go to this example. So we have this example. So we have this function, polynomial function. So g of x equals to 3 plus 5x. Now at first, let's write in a standard form. Okay, so writing in a standard form means we write our each term in the descending order of exponent of the variable. Our variable is x, right? Our input is x. So what is it? Has a coefficient, exponent is 0, right? This is a constant, and it has an exponent, so 1, right? So let's write 5x plus 3. These two are the same thing. Okay, do not get confused. We are just writing in a standard form. Now we need to find, is this a polynomial function or not? So for that, we need to check whether this is the output here. We want to know whether this output is a polynomial or not. We have a 5x plus 3. Is this polynomial? Okay, what makes you think it's a polynomial?
Because it's having 2 terms and it's a binomial.
Is that enough? Okay, now if we have something like okay, so let me call, we have x to the power 1/2 plus 2. Now is this a polynomial? Okay, so we have a 2 terms, but the key here is that we need to check the exponent. We want our exponent to be a whole number. So what is the exponent of this x? It's a 1, right? And 3 always has a 3 can be rewritten as x, 3 times x to the power 0. So we have 0, 1 as exponent, and 0, 1 are the whole number. That's the key here. So we want the exponent of the input as a whole number. Okay, if you find a whole number, it's a polynomial. So yes, this is a polynomial function. Okay, next we need to find the degree and coefficient. Okay, now so this is yes. Now what is the degree of this term? So what is the degree of 5x? 1. What is the degree of this 3? 0. And the highest degree is 1, right? So degree for this function is 1. So degree is 1. The highest degree is the 1. The next we need to find the coefficient and identify the leading term. Okay, let's find the coefficient. So you should have the leading coefficient. Okay, so it does tell us to find the coefficient. So we can just find the coefficient for each term. Okay, like we have 5x. So what is the coefficient for this term? 5, right? The number in front of the input x, the coefficient. So we have coefficient is 5, right? And constant by itself is also a coefficient. So coefficient is a number in front of the variable. Okay, those are the coefficient. And next we need to find the leading coefficient. And leading coefficient is 5. It's a coefficient with a coefficient of a term with the highest degree. So we have this term with the highest degree. Its coefficient is 5. So 5 is the leading coefficient. Okay. Now similarly, let's go to the next function, number b. Okay, so we have, let's rewrite this at first. We have h of s equals to 2s times s square minus 1. So how can we write this in our standard form of a polynomial function? What do we need to do? we distribute. Okay, that's right. So let's distribute 2s for s square and -1. So we have 2s times s square is 2s cube. 2s times -1 is -2s. Okay, let's write the degree of each term. What is the degree of first term? 3. So this is the degree of each term. Okay. What is the degree of the second term? 1. Okay. Now if this is the case, now at first, is this a polynomial or not? Yes. This is yes, polynomial. Okay. What is the degree of this this function? 3 is the degree. What are the coefficient? 2 and -2. Okay, the number in front of variable, our s is the variable, we have 2 in front, we have -2. So these are the coefficient. And what is the leading coefficient? +2. Okay, leading coefficient is +2. Okay, now we have last here, number C, and our function f of x is equals to square root of x square plus 1. Now here, okay, I'm not sure I mentioned this or not. Did I mention how to how to get rid of this radical sign, or how to write this expression without using radical sign? Okay, now here, so let's make a revision. So if we have a radical expression, let's say we have a to the power n and we have m. What do we call this m? Do you remember what do we call this? It's a index. So this m is the index here. So we call this m as a index. So this is okay, and this sign is the radical sign. Radical. Okay, and whatever we have inside the radical sign, we call this radicand. Okay, so this m, like whatever number we have here, is the index. Okay, this sign is the radical sign, and whatever we have under the radical sign is the radicand. And we can, yes.
Isn't it like our root?
Yes. So if we have a radical expression, then we can always rewrite this without using radical sign. Okay. So here we can rewrite this as a, so we write down whatever we have under the radical sign. We have a to the power n. Okay. And this index is the denominator for this exponent here. So we have a to the power n divided by m. Okay, so we always write the index as the denominator of the exponent of radicand. Okay, and if you have a fraction as an exponent, you can always rewrite this as using a radical sign. Okay, for example, if we have something like a to the power 5/6, then we can rewrite this using a radical sign. Okay, so using a radical sign, and here denominator is the index, so we write down 6 here, and the remaining a to the power 5 under the radical sign. Okay, we can always rewrite the radical expression without using radical sign. Okay, or if we have a fraction as an exponent, then we can rewrite that using a radical sign. Okay, now in the similar way, so we have, now for this radical expression, what is the index here? So what is m? So this is square root, right? So it's always 2. Okay, we don't write 2. If you write, it's not wrong, but in general we don't write 2. Okay, like for example, we don't write coefficient 1, right? Every time we don't write the exponent 1, but we understand it. The exponent is 1, the coefficient is 1. In the similar way, if we have a square root, the index is always 2. Okay, so here we're gonna write this without using radical sign. So let's write whatever we have under the radical sign. We have x squared plus 1. This is what we have under radical sign. And what is the exponent of this radicand? So our radicand is whatever we have under this radical sign. Now what is the exponent here? What is the power of this radicand? If you take x square, then 2 is the, but we are taking all this term. We are taking whatever we have under the radical sign. So we have x square plus 1. So what is this exponent? If it's nothing, it's always 1. Okay. So we can rewrite our x square plus 1 as a x square plus 1 to the power 1. Okay. Divided by, now this by the index, which is 2. So let me write one more. So this is same as x square plus 1 to the power 1/2. Okay, so you are dividing the exponent of radicand by the index. Okay, now this is the function we have here. Now is this function a polynomial or not? So what is our exponent is in the fraction, right? So this is not a polynomial. So this is not a polynomial here. And if it's not a polynomial, we don't define the degree. Okay, there is no point of defining degree, coefficient, or leading term. If it's polynomial, then yes, we go for the degree. If you are asked, you need to find the degree. Okay, you need to find the leading coefficient. Okay, this is all about what is polynomial function. Let me know if you have any question. Okay, a quick question for you. If we have h of t equals to square root of t plus 3, is this polynomial function? So square root of t plus 3, is this polynomial function? Is it polynomial function? No. Okay, what is the reason?
Because you can rewrite t as t
Okay.
to the power 1/2.
Yes, so we can rewrite t as a t to the power 1/2 plus 3. And this 1/2 is not a whole number. This is a fraction. And so this is not a polynomial function. Okay. So this is not a polynomial function. Okay. Now, in this unit, we also need to discuss the graph of the polynomial function. Okay. Before this leading term test, let's see some of the function. Then we'll start this one. Okay. Before this one, so let me take a function. So if we have a function f of x equals to x cube. Now, is this a polynomial function or not?
Yes.
What is its degree? 3. What is the coefficient? What is the leading coefficient? 1. Okay. Now, so this is a cubic function, right? Now, we know the shape of the graph of this function, right? So from our section 2.8, this is our basic function for a cubic function. And the shape of a graph, so this is the graph of this cubic function. Now, for this function, what happens if we choose our input x to be a very big number? We use infinity, okay? So we choose our input to be a big number. What happens to our output? What happens to our output? So do we get a big number or a small number? Big, right? So our output goes to the infinity. It means when you have your x value bigger, it means all the way to the right, your graph goes all the way to the up, right? So it means our graph goes all the way to up. Okay. So it means that we can extend this graph all the way to the positive infinity. In the similar way, if we choose our x input to be very small number, like negative infinity, very small, like negative 0.000, like some number at the end. So what happens to our output? Do we get a output small or big? We get the small, right? So it means we get the small negative infinity. What it means here is that as we go all the way to the left, our graph go all the way to the down, which is negative infinity, right? So we have negative infinity here, we have positive infinity here, we have negative infinity here, we have positive infinity here. So as we go all the way to the left, negative infinity, our graph goes all the way to the down. It means negative infinity. Okay. In the similar way, let me take a different function. So let me take a function x to the power 4. So our function f of x is, let me take x square. So this is also a polynomial function, and it does have a specific name, right? What do we call this function? This is a polynomial. It's a quadratic function. So if we have a degree 2, that is a quadratic function. So quadratic function is also polynomial function. And we also had a linear function, and linear function is also a polynomial with a degree 1. So if you have a function with a degree 1, that is a linear. If you have a function with a degree 2, it's a quadratic, okay? And if you have a function with a degree 3, it's a cubic function. Okay, and what is the shape of graph for this function? Parabola, right? Now, similarly, so as we take our input, x is the input, very big, positive infinity, our output is also very big, right? So it means as we go all the way to the right, our graph goes all the way to the up. It means towards positive infinity. If we choose our x to be very small number, it means negative infinity, our output is f of x is also, our f of x goes to very small number. Oh, now in this case, does it go to small number or big number? So we have a negative number, right? See, it always make a positive, okay? So here it goes to a big number. So we can see this on the graph, like as we go all the way to the left, our graph goes all the way to the up. It means it gets bigger, okay? Since we have this square, if you even take a negative number, square make it positive, okay? We always get the bigger number. Okay, now if we compare here, so if the degree, so here from this example we can just generalize here, and that's what we're gonna have here in the leading term test, okay? So this is the test here. It helps us to know how the function behave on the left and on the right. It means like when we choose our input to be very big or when we choose our input to be very small, what happens to the function or what happens to the output? Is our output very big or small? Okay, so that's what we're gonna get from this leading term test. Okay, it helps us to know what is the shape of graph at the end. We may not know what happens in the middle, but we will know what happens on the right end and the left end from this test. Okay, now let's see. So let's consider we have this polynomial function with a degree n and an as a coefficient of leading term. So these are the two things that we need for this test. So n is we use n for the degree of the polynomial function, and an is the coefficient of a leading term. Okay, now if we have, so let's say if we have our degree, so we have a degree here, an, this is the coefficient of leading term. Okay, so an is the coefficient of leading term, coefficient of leading term, and the next we want to know how the graph behaves on the left and right. So we want to know the graph. Okay, now if our degree is n here, okay, if our degree is even, so we have a even degree. Even degree means 2, 4, 6, 8, right? So let's consider we have a function with an even degree and the coefficient of leading term an is greater than 0. So we have an even degree and the coefficient of leading term is greater than 0. Then on the left and right, the graph of this kind of function looks like this. So on the left, we're going to get this kind of graph. On the right, we're going to get this kind of graph. And we don't know what happens in the middle. We can have anything, any type of graph in the middle, okay? We don't know. Only what we know here is that this is the shape of graph on the left. This is the shape of graph on the right. If the degree is even, and the coefficient of leading term is greater than 0. Okay, if the coefficient of leading term is greater than 0 and is even, we're gonna have a like a parabola shape. Okay, it's pretty similar to the parabola, but in the middle we can have any graph. Like for example, so we might have a graph like this. Now if this is a graph, what can we say? This function has a even degree and the coefficient is greater than 0. Okay, similarly if we have an, the coefficient of leading term less than 0, what would happen? Can you give a guess here? So degree is even, the degree is still even, but our coefficient is less than 0, it flips. That's right. So there will be a reflection across x-axis. So on the left our graph looks like this. Okay, on the right our graph looks like this, and we don't need to worry about what happens in the middle. Okay, we don't need to worry. We just want to know what happens to the graph on the left and on the right. Okay, now the next case would be for the odd. Now if our degree is odd, okay, can I, okay, let me erase my question for a second. Okay, so let me continue here. So let's take our degree is odd now. So we have a order degree. So our order degree means 1, 3, right, 5, 7. If degree is odd and the coefficient of leading term is greater than 0, okay, then we're going to have a graph that looks like this. So we're going to have a graph. This is the graph. Okay, if the degree is odd and the coefficient is positive, this is the graph. So if we have like cubic function, just remember the cubic function. The shape of cubic function is like this, right? See, on the end, we are interested in the end. So this is the what happens at the end. That's what we have here. And this is what happens on the right hand. That's what we have here. So this is the shape of graph. If the degree is odd and the coefficient of leading term is greater than 0. What would be the case if the coefficient of leading term is less than 0? Yes, there occurs a reflection across x-axis. Okay, and the graph is, it's on the other way. Okay, so you have this on the left. We don't know what happens on the in the middle, and this is the part on the right. So this is the case when our coefficient of leading term is less than 0. And once we have this information, we can know the shape of a graph on the right hand and a left hand. Okay, and this is our leading term test. Okay, and end behavior, because if we have a leading term, or if we can identify a leading term correctly, we can find the shape of the graph here. Okay, let's do some example here. Okay, let's take an example here. So our function f of x is x cubed plus 3x squared plus x, and we want to know how the function behave at the end. Okay, now at first we need to know the leading term. Now what is the leading term here? What term is the leading term? 3x. Is it x to the power 3 or x cubed, right? So this is the leading term. Okay, once we have the leading term, we need to know what is this degree. Our degree is 3, right? Is it odd or even? Odd. What is its coefficient? 1. So we have an odd degree with positive coefficient. Now let's go back to our table here. So we have an odd degree and the coefficient is greater than 0. So this is the graph. The graph of this function looks like this one. So our end behavior. So we're going to have a graph on the left, this kind. Okay, we don't know what happens in the middle. And this is the graph that we get on the right side. Okay, so we are only interested in the left end and on the right end. So let me take a different function. F of x equals to negative 2t to the power 4 plus 8t squared. Now you don't need to plot a point here to know the shape of a graph. We can use this test to know the shape of a graph here. Now for this function, what is the leading term? That's what you need to know at first. Which one is the leading term? Negative 2t to the power 4 is the leading term. Okay, what is this degree? Degree is even or odd? Is even. And is the coefficient positive or negative? Negative. So let's go back here. So we have an even degree. So we have an even degree and the coefficient is less than 0. So this is the graph that we're going to get on the left end and right end. So on the left, we're going to have this part. On the right, we're going to have this part. And we are not interested what happens here. Okay. So this is what we're going to have on the left. And this is what we're going to have on the right. Okay. So this is how we can find like how the function behave on the left end and right end with the help of leading term. You should know the degree, you should know the coefficient and the table. Yes.
On the homework, can we just put arrows or do we have to?
So if you are asked to determine the leading term test, you just draw this graph. Okay, you don't need to describe. You just draw the correct graph. Okay, so this is the leading term test. Yes.
So we don't have to put like as x goes to negative.
No, you don't need to. So if you are asked to determine the end behavior of the function, you just draw the graph on the left end and on the right end. Okay. All right. Let's do this much for today. Okay. Remaining we'll do in our tomorrow class. So if you have any